At some point in time, you're going to need to create a sheet so that you can issue your drawing. Whether this is in the time-honoured tradition of paper or as an electronic copy, you're still going to want to be able to track your documentation. From your Chapter 18 folder, open the file Chapter 18 Setting Up Sheets. Here you can see that the project browser is organised slightly differently to previous exercises. The views have been filtered. If I right-click and click on Type Properties, I can have several different types of view filters created so we can see the project differently at different stages of the project. Here you can see that there's a design folder with a whole bunch of views in here, and another folder for documentation. What I want to do now is start creating sheets that I can put these views onto. From the View tab, on the Sheet Composition panel, click on Sheet. Here I can choose the title block that I want to use from my sheet, or click on Load, browse to my title block folders in my library, and load the appropriate title blocks for use in my project. I can then select the one that I want to use and click on OK. This sheet is now visible in the project browser. Here you can see we have sheet E103. It's unnamed, and that corresponds to the data that's on the actual sheet itself. So I can change this data on the sheet, and let's change this to M501 and change the sheet name to Level 1 HVAC North. Changing that on the sheet has also changed it in the project browser. This is yet another indication of the power of Revit, changing something in one location and it changes it everywhere. There's currently no scale assigned, as the scale is drawn from the view that's placed on the sheet. We do need to fill some of this information out. Project number, author, and who checked it. You can see that information I've just changed has also been changed in the Properties palette. This information can be changed in other places. From the Manage tab, click on Project Information. Here we have the project name, and when I click on OK, that updates the title block. Also notice under Project Information, we have the project number. If I change this, it'll also change on the sheet. Let's zoom to fit and place a view on a sheet. This is as easy as finding the view that you want on the sheet, selecting it and dragging it into place on the sheet. It has the view name, the scale, and the detail number. If we scroll back to the details of the sheet, you can see that we now have a scale. The view title looks a little long, especially this line that runs along underneath it. Simply select the viewport and drag the grip to make the line the length that you require. If you actually want this title to be somewhere else, then select and drag the title. You can also choose from predefined viewport types. These will be set up in your project template. So let's run through that one again. Click on View, click on Sheet, pick your sheet size, and click on OK. Now see that the next sheet created has been numbered sequentially from the previous one. A certain level of the information has come through, as with before. There's the sheet number, there's currently no author, the project number is updated, and the project title is there. Sheets cannot have the same number. If I try and change this, it tells me I need a unique number. If I change it to an earlier number, then the project browser resorts itself. For this exercise, open the file Chapter 18 Placeholder Sheets. If you do standard projects, or you want to create a sheet list before you've actually done your drawings, then placeholder sheets are a great tool. This can be done in a project template, and it also can be done in a project as we're doing now. From your View tab, click on Schedules, and here we're going to create a sheet list. In the Available Fields column, scroll down until you find Sheet Number, double-click on it, and Sheet Name, double-click on that too. This adds the fields to the right-hand column. Click on the Sorting and Grouping tab and sort by Sheet Number. Make sure that Itemize Every Instance has a check in it, and click on OK. This has now given me a sheet list of all the sheets available in the project, and we can see them here in the project browser. What I'd like to do now is create some new placeholder sheets. I can do this by clicking on New Row. This creates a new row in my schedule without actually creating the sheet in the project browser. So I can add another 10 sheets if I want. If I really wanted to, I could add 100. And at this point, I can start naming them as well. So let's just go through that process. I'm going to make this one Level 1 HVAC South. I'll repeat that for Level 2. The only thing I have to do is come through and change one character, and repeat that for Level 3. Let's go with North, Centre, and South. So we can start here with 3, 3, and 3. Let's delete that row for the time being. It tells me that it will delete one selected sheet, but it's not in our project yet. So I can click on OK. Let's go back to the View tab and click on Sheet. Here I can select the title block I want to use, and then select, by using my Control button, the sheets that I want to create. I can now click on OK, and that populates my project browser with my sheets. Remember in my first sheet, when I created this, I created it with an A1 sheet. I added the subsequent sheets as A0s. I don't need to go and delete them and remake them again. What I can do is select one of the sheets, right-click on it, and select all instances. If I select all instances in the entire project, Revit tells me with the filter that I've got 3 selected. From the Properties palette, I can now go and change these to the A1s. And that's changed all of them. From your Startup screen, browse to the Chapter 18 folder and open the file Chapter 18 Guide Grids. There's no getting away from it. Guide grids are for the sticklers amongst us. The people who want their documentation to look exactly the same. They want their north part of the building in the same place on every single sheet. As a CAD manager, it drove me nuts that people couldn't manage to do that. And its simplicity itself in Revit. Let's take a look at a sheet that already has a guide grid set up. In your project browser, scroll down to M501 and open the sheet. This has a guide grid on it. It's a guide grid and it has a name North. So let's take a look at the process for creating one of these. Open M502 and from the View tab on the Sheet Composition panel, click on Guide Grid. We can either choose an existing guide grid or create a new one. Let's create a new one and we'll call it Centre. Click on OK. This gives us a guide grid which we can move and stretch to suit our project. We could move it or size it in such a way that the final intersection of these lines coincides with a grid intersection. But we don't know that until we place a view on the sheet. So let's go and grab one of our centre sections and drag it onto the sheet. I'll place the view on the sheet and then take a look at the guide grid. Let's just stretch it a little bit more and then select the viewport. I can move the viewport using grid intersections and then find an intersection on the guide grid. I can now stretch the guide grid so that we now have that last intersection. And that's done. Let's just scroll down and have a look at the other sheets. Here's M504. If I open 504, I can scroll down in the Properties palette, and under the other section, we have Guide Grid, and I can set that to Centre. I can now drag my Level 2 centre plan onto the sheet. That's if I had one preset up. But let's do that right now. There's my Level 2 HVAC duct plan, and I'd like to have these dependent views set up from it. Right-click on my plan and apply those dependent views to Level 2 HVAC duct plan. The naming of these won't be correct, and I will have to go into these and name them afterwards. But I can double-click on these and find my centre plan. We can drag that onto the sheet. And using the guide grid, move my viewport using the same intersection points. Now this looks all too easy, except when you get onto a bigger project. I don't want to have to go through each sheet and assign the guide grid. So let's go back to my schedule. On my sheet list, let's look at the fields. If I scroll down in available fields, I can pick up guide grid and add it to the scheduled fields. You can now see that we've got our guide grids displayed in the schedule. I keep reinforcing the fact that I don't like work. So here's a little tip for filling out all the rest. Let's go to Filter and filter by sheet name, and I'll say it contains North. I have to be very specific here and have this case sensitive. I now want to go to sorting and grouping and not itemize every instance, and click on OK. We now have one North that's assigned and one that isn't. If I click on there, come back to Filters and remove the filter and make sure that I itemize every instance. You can see that we've got Centre, and that's already done. All we need to do now is assign the South ones. We can check this on the sheets, and each centre view has the centre guide grid. Consistent documentation is easy. From the Startup screen, click on Open, browse to your Chapter 18 folder, and open the file Chapter 18 Printing. In the project browser, scroll down until you find sheet M501, Level 1 HVAC North. In this exercise, we're going to look at how we create output, that is, print to a sheet of paper, and some of the options that are available for you. From the Application button, click on Print. You can see I've got some default printers installed. I'm going to go with PDF Creator for this exercise, and what I want to do is look at the settings down at the bottom right-hand corner of the dialog box. In here we've got a name for my print setup. We've got a paper size. Well, I know that my sheet is an A1. I need to choose whether this is going to be placed in the centre of the sheet or offset from the corner, whether we have a margin, and whether we're going to fit to a page or zoom. Well, I always like my drawings to be 100%. Our orientation is landscape. We're going to use vector processing in this instance for removing lines. I want presentation quality and black lines for my print. At the bottom here, I've got some other options. Do I want to view links in blue? Do I want to hide reference and work planes? Well, generally they're messy and you don't want those showing on your drawings. Do I want to hide scope boxes and crop boundaries? Well, again, they're really for construction. And hiding unreferenced view tags. If this is a construction set of documentation, I don't want anything unreferenced on my drawings. And finally, don't want to replace halftone with thin lines. If you're using halftone on the architectural model, sometimes it doesn't print out quite as well as you'd expect. So you can replace halftone with the thinnest lines available. Once I've set these up, I can save this as a printer setting. Let's call it PDF Creator A1 full size. And click on OK. Click on OK again. What do we want to print? The current window, a visible portion of the current window, or selected sheets? Well, let's start with the current window and do a preview. I can tell you now that this preview looks horrid. The only reason we've got this preview here is to make sure that we're getting in the whole of our sheet. There's no other purpose to it. It looks like I'm missing half my drawing. But I'm actually happy that I can see the extents of my title sheet. So let's click on Print. I can now click on OK. This sets up my print job. I can browse to my project folder and click Save. I can then open up the PDF to examine my drawing. And this is exactly what we were after. Let's try that command again, this time with selected views and sheets. I'll click on Select, and I only want to see sheets. Put a check mark in all the North sheets. We'll save this as a list and we'll call it North Check Set, and click on OK. Click on OK again. Click on OK to print, and this sends the job to the printer. We'll save my print job. This goes through the 3 sheets, and you can see that I've got something to check on, as my Level 2 HVAC North is showing a central plan. And Level 3 North doesn't have anything on it at all. But as you can see, this process is fairly painless. If I go back to the print command again, you'll see that we now have a North check set available to us. And if I select it, it will have selected just those North sheets. In your current CAD program, you're probably using text to annotate your drawings. If you're lucky, you're using an attributed block. Tags are a huge leap from attributed blocks. They extract information from your model and report it in the way that you set them up. There's still a place for text in the Revit environment, but it's starting to take a backseat. Let's take a look at this in a model. From your startup screen, click on Open, browse to your Chapter 18 folder, and open the file Chapter 18 Tags versus Text. With the project open, check in the project browser that you have sheet M501 Level 1 HVAC North open, and scroll into the top of the screen. From the Annotate tab, click on Text. Select your preferred text style and place the start. Here I can create some general notation. Let's make them numbered bullets and start writing text. Check all dimensions on site. Do not scale. So you can see we can place text in exactly the same way as we can in a CAD program. And just as everything in Revit or a CAD program, there are hundreds of ways of doing this. We could create these text notes in a legend and then place the legend on the appropriate sheets. Or we could make it part of the title block and then it appears on every sheet. With tags, it's a whole different ballgame. From your project browser, scroll up until you find Mechanical, Level 1 HVAC Duct Plan, and double-click to open. If I scroll into the north part of the plan, you can see that we have our drawing, but no annotation. And I could put text notes here, but there's absolutely no point. Let's see why. From the Annotate tab again, click on Tag by Category. Here I can choose whether I want a leader or not, whether it's an attached end or a free end leader, and the type of tab that I want to use for that particular object. And if I don't have one, I can load one from my library. I can uncheck leader. That might mean that I have to move the tag after placement, but that's not hard. And I can go around doing this to all the objects in the plan. Let's try that again with a duct. Now here I've got a tag that's reporting the bottom of the duct at 2900. I can come back and change the tag so it reports the size. Or if I do that process again, I can select tags from the options bar, scroll down to duct, and choose the one that I want to be the default. Now the whole purpose of the tag is that if any change is made to the object, then the tag changes. Now you can see here that we've got an error message as well, which relates to an element being too small to be created. So I've got two options, either cancel the command or delete the elements. The information contained in the tags is directly related to the object. If I select the air terminal, the flow is displayed on the options bar, and here you can see the flow in the tag. I can change the flow here in the options bar, and it changes in the tag. This also shows in the properties palette. But what about the rest of the drawing? Have I really got to go around and place a tag on all those elements one by one? Well, no you don't. You've got the option to tag all. This will do things like tag all objects in the current view. There's my air terminal tag, there's the name, and if I click on Apply, it tags every single diffuser in the view. If needs be, we can go around and move them to suit. I can even tag elements from linked files. So in this case, I want to tag all the architectural rooms so I can show room names on my drawings. It gives me more flexibility than showing the architect's actual room tags, because I can move them once they're placed. And these can be moved to suit my drawings as well. Any changes made to the architectural plan will be reflected in mine. Tags are another really powerful tool in the Revit MEP toolbox, and are another way of making your documentation consistent. For this exercise, click on Open, browse to your Chapter 18 folder, and open up the file Chapter 18 Dimensions. From the project browser, scroll down to the Plumbing section and make sure you have Level 1 Fire Protection Piping Plan open. So before we start dimensioning, here's a couple of things. When you're dimensioning to objects, always try and dimension to objects that are in your file. So if we were going to dimension this sprinkler pipework, and we're going to dimension it against the architect's file, I'm not going to dimension between my sprinkler pipework and a wall. One of the reasons for this is that architects kind of like deleting things when all they need to do is change them. So I always dimension to my copy monitored grids, and I make sure that the architect's grids are turned off in the view. The main reason for this being, when the architect issues you a new file and you get the coordination review message come up, you can check that any changes he's made to the grids don't include deleting them, because as soon as a grid disappears, all your dimensions will go too. But you won't have that check if you do your dimension to a wall. Unless, of course, you copy monitor all the walls as well. But that's really going to go too far, especially if you're working on a large project. So with all that said, let's look at the Dimension tool. From the Annotate tab, we've got the Dimensioning tool. Here you can see we can click on Aligned, Linear, Angular, Radial, New to Revit MEP 2013, Diameter, Arc Length. We can also do spot elevations, spot coordinates and spot slopes. Here I'm just going to go with the aligned dimension. My contextual tab changes, and at this point I'm going to dimension between the actual pipes themselves and click to place the dimension. Let's scroll in and see the dimensions we have. I've currently got a match line in the way, so I'm going to temporarily hide that. And we can now see that we've got 3600 for the first two segments and 3771 for the last one. So I can change that by selecting the pipe and changing my dimension. Notice how it pulls everything that's connected down with it. Now these dimensions are equal, and I could apply an equality dimension to them. This means that changes made to one will reflect in all of them. Now that these dimensions are spaced equally, I can select one of the pipes and do one of two things. I can either change the entire length and the dimensions stay equally spaced, or I can drag the grips for the temporary dimension and change one. So that's shown you how flexible the equal constraint is. If I delete this dimension, however, I'll get a message, and it tells me a dimension with a lock or an equal constraint is being deleted, but the elements will still be constrained. Push Unconstrain to remove the constraints, or OK to leave the elements constrained. Well, let's click on OK and see what happens. There's nothing appearing in my drawing, but if I select one of the pipes, you'll see that we still have this equal constraint. Here it is here. It's almost like the dimension is still there, but it's not, it's the constraint. And with it selected, I can delete it. If I want to, that is. If you did want to have these pipes constrained, it's always a good idea to have the dimensions somewhere. Maybe having a view that's a design view that shows your constraining dimensions. So let's delete this one for the time being. And I'm going to put another dimension in here between my grid line and one of the vertical pipes. If I select the vertical pipe and change my dimension, the whole pipe run moves, and selecting the dimension, I can pick on this padlock. The padlock means that these pipes can now not move. So Revit is trying to move the pipes, but it's telling me the constraints are not satisfied. I can either remove the constraints or click on Cancel. We get the same behaviour if I delete this dimension. We'll get the warning that can be ignored, with the lock constraint now being in place. This time I'll unconstrain it. We can see from here that the dimensioning tool is a very powerful one, as are the constraints, and the constraints should be used with a bit of care. Maybe you do want your pipe to always be 4 meters from the grid line, but the more constraints you put into your model, the harder it becomes, especially in the early stages, to move things. And this can lead to problems when you're trying to move a sprinkler on level 1 and a pipe on level 4 is preventing you from doing it. So only constrain the really important things, the things that cannot move.